Another quick thing you could do to see if you're in the if you are wrong or not. If this number was for any reason less than this number, remember the average V here, 1.75. If that number was less than 1.75, you're wrong. One of them is wrong. The average can't be greater than the final. The average has to be between the initial and the final. The initial was 0. The final is has to be greater than the 1.75, and then that one needs to be greater than that, which it is, you know. So that's good. It doesn't prove that it's right, but at least it shows that it is not wrong. So that's the final velocity, initial velocity. This, as far as the speed is the magnitude of the velocity vector. So initial speed is 0. The final speed is the magnitude of that. So square root of plus 104.99 squared. So 8.73 squared plus 104.99 squared. And that gives you the final speed. You'll get a certain number, and that's the final speed. And then acceleration. Initial acceleration. You put t equals to 0 into the acceleration function. 0, 0, 0. So it's all 0. Initial acceleration is 0. So 0 I hat plus 0 j hat meters per second squared. The final acceleration is, again, you put, it's going to be messy there, but you put 1.719 into that equation. You get a certain number I hat plus a certain number j hat. This really tests if you can put numbers into your calculator, do all those powers and stuff. Let's see here. I'm going to try it too. See if I get the right answer. You can test me out here. .32. Am I right? You see, students check me. See if I'm keeping on track, if my skills are sharp. Okay. Now let's see here. 12 times 1.719 to the power 3 times it's going to be a huge number. $1,160. Right? It's kind of on the slow side. I went a little slow, but I'll get there, you know. 1160.15 meters per second squared. So this particle is just zooming. Okay? Huge acceleration. Is that right? Anyone else got that? Okay. No? Yes? Okay, now you could see if you get that. Now we could also go back. We're almost done. We can also go back, and now we could calculate the average acceleration. The first part was asking us what is the average acceleration. So final velocity, which is 8.73 divided by 1.719 So this is going to give you meters per second squared again. So you divide that by that. And you'll get the average acceleration here. Again, it's pretty huge acceleration. Now, the final acceleration should be larger than that, which it is. See, this is 5. That one is 20 I had. This one is 61. That was is 1,160. So it's bigger. So it's making sense. And another interesting thing that you can kind of see here, the velocity here should be tangential to the path. So it's telling us by the time the particle gets here, its velocity is 8.73, 104.99. If you draw the velocity vector, you will notice that the velocity vector here, the final velocity vector, is tangential to the path. The velocity is always tangent. The acceleration vector doesn't have to be, and it's not. The acceleration vector is 20 and 11. The acceleration vector can be, let's say, 20 and 11. It's probably going to have either a less or greater. So it's probably accelerating this way. I would venture to say, if we found the angle of the acceleration vector, the angle, I'm going to guess something here. I'm going to guess that the angle of the acceleration vector is probably going to be higher than the angle of the velocity vector. Let me see if I'm right here. I'm going to take the tangent inverse of the 1160 divided by 20.32, 88.99 degrees. So the acceleration vector is almost facing up, right? So it looks something like this. Let's say the point is here. The acceleration vector is facing almost like that, the final acceleration vector. And the velocity vector is this 104.99 divided by 8.73. $85.24. I was right, you see. So velocity vector is like this. So the velocity vector is tangential to the path that it's taking. But the acceleration vector is a description of the forces on the particle, right? So while this thing is going like this, something is pushing up on it like that, which is causing it eventually to curve like that, you see? If it's going like that, I push on it like that, it goes like that. I push on it like that, it goes like that, you see? So the velocity is tangential to the path, but the acceleration is a description of what are the forces on the particle. So that's why I want you to not only be able to do the math, but be able to understand what it means, you know, what the particle is doing. Okay, did I see a hand? I think I saw somebody. Question? Did we fully explain everything here? I believe we finished the problem, right?